Today we're going to look at Lesson 8, and Lesson 8 comes from Part 2 of Section 6 in your textbook. So the first part of Section 6 was Lesson 7. We were solving absolute value equations. Today we're going to be solving absolute value inequalities. So they're very similar. Just like before, we solved equations and then inequalities. We solved absolute value equations, and now we're going to do absolute value inequalities. So as usual, get your notebook, make sure you write down the notes as we go, write down the examples, and follow along with us. I will go faster in the video than I normally would in person, so feel free to pause or rewind whenever you need to. When we're solving absolute value inequalities, you're going to follow the exact same steps that we wrote down in Lesson 7, except when you make your second inequality, you're going to flip that symbol and the sign. So before, you had to have one equation equal to a positive and one equal to a negative. Now, when you do that, you're going to have a positive and a negative, but you're also going to flip that symbol. So greater than will turn to less than, or less than will turn to greater than. Another thing we need to remember when working with inequalities is that you flip the symbol when you multiply or divide both sides by a negative. So if you're multiplying both sides by a negative, you're dividing both sides by a negative, you have to flip that inequality symbol around. Okay, the last little note we need to make before we do some examples is that these are really compound inequalities. When we talked about compound inequalities, we said that's when we have two distinct inequalities and we're talking about them together. We're solving them together, putting them on the number line together. So absolute value inequalities are really two separate inequalities that we're talking about at the same time. So just like with the equations, you had to make two equations. We're still going to do that. We're going to make two inequalities. And so sometimes your inequalities are going to be and sometimes they're going to be or. So a quick little tip to help you know which one's which and what your answers are going to look like is this. So if your original inequality is greater than, it's going to turn into an or inequality most of the time. So that means you'll have this answer or that answer. Okay? Usually if it's a less than, it's going to turn into an and inequality. That means it's this solution, and your graphs are stuck together, and then your answers are going to get put together. So we'll practice that as we go along, but just a little hint that could help you in the long run. Okay, here's example number 1. The absolute value of the quantity x plus 5 is greater than 3. Okay, so let's think through our steps. Step 1, get rid of any operations on the outside of the bars. We don't have anything, so we can move on. Step 2, make two equations, or in this case, inequalities. So, and that's what gets rid of the bars. So our first one is going to be x plus 5 is greater than 3. And our other one is going to be x plus 5. We flip the symbol, so less than, and we change positive 3 to negative 3. And now I realize that that pen is not showing up very well, so let me grab a different one real quick. Now, each of these are one-step inequalities, so take just a second, solve those, and see what you get. All right, to solve the first one, we will subtract 5 on both sides, and we get x is greater than negative 2. And on the other one, we subtract 5 and get x is less than negative 8. And so, a little hint, we started out with greater than, so this is going to be an or. So it's x is greater than negative 2 or less than negative 8. So that means when we look at it on the number line, our arrows should be going in two opposite directions. They should be going to the two ends of the graph. So let's check that and see. So sketch a little number line. On the number line, negative 8 is on this side, negative 2 is on that side. So on x is greater than negative 2, that's an open circle, and greater than is to the right. Right. On the other one, less than is an open circle on negative 8, and we're going to the left. So that is an or compound inequality. because your graph is going to the two outside edges. So there are two parts of your solution here. You've got your solutions. We'll throw in the or, and then you've got your graph. So you will have to do both parts, I think, on most of your Math Excel problems. Okay, here's number 2. It's very, very similar to number 1. So take just a second and give it a try. See what you can do. All right, we don't have any operations on the outside of the bar, so let's go straight to 2 inequalities. X minus 6 is less than or equal to 4. X minus 6 is greater than or equal to negative 4. Remember, flip the symbol and the sign on that second one. All right, let's solve them. So we add 6, and we get x is less than or equal to 10. On the other one, we're going to add 6, and we get x is greater than or equal to 2. Now, let's think about it for just a second. So this one is a less than, so it should turn into an and. So we should have x is less than or equal to 10 and x is greater than or equal to 2. So since it's an and, we're going to have to squish our answers together like we did back in lesson 6, I believe. So let's rewrite that. Let's put x in the middle. It's smaller than 10, but it's bigger than 2. All right, and then we can put it on the number line. And what might help you here is to think about a number line first. Now, I know in Math Excel, it wants you to do the answer and then the number line. But if it helps you, sketch out the number line first on paper and then go back and type in your answer. And that might be a little bit easier for you. So x is less than or equal to 10. That 10 has a closed circle. It's greater than or equal to 2 that has a closed circle. And if it's less than 10 and greater than 2, it's right in the middle. Okay? So an and compound inequality does have the shading or the line or the arrows in the middle. Okay? And if this helps you write your answer this way, do this first. Okay? Our line, our solutions are in the middle. Our x is in the middle. So here are the two parts to that solution as well. Okay, here is example number 3. Take a look at that, and what do you see that's a little bit different? That's right, we have an operation outside the bars. So we're going to treat it just like we would any other equation. If we're adding 5, how do we get it to move to the other side? We subtract. So I'm going to subtract 5. And I have the absolute value of 2x minus 1 is less than 7. Okay? Now I'm going to finish the problem out just like I did 1 and 2. So you can take just a second, pause the video, give that a try. All right, let's see what you did. So from here, we can take away the bars and make 2 inequalities. 2x minus 1 is less than 7. 2x minus 1 is greater than negative 7. All right, solve each of those. 2x is less than 8, so x is less than 4. 2x is greater than negative 6, so x is greater than negative 3. All right, so we've got less than 4 and greater than negative 3. Let's think just a second. Is it going to be or and? Our original was less than, so it should be an and. Should be and. Okay, so let's think. So it's smaller than 4 and greater than negative 3. Let's put x in the middle. So it's smaller than 4, but it's bigger than negative 3. Then we can put it on a number line, or again, like I said, if it's easier, you can do the number line first. So like I could sketch this out. It's less than 4, greater than negative 3. I see that my line meets in the middle, so that means my x will be in the middle in my inequality. Okay. Okay, here's example number 4. It's very, very similar to example number 3. So pause the video, give it a try, see what you can do. Okay, now let's talk about it. So look on the outside of the bars. Do you see an operation? Yeah, we have a plus 3. How do we get rid of a plus 3? We subtract. So subtract 3. We have the absolute value of 6x minus 3 is less than 15. Now, there's nothing left on the outside of the bars, so let's make our two inequalities. 6x minus 3 is less than 15, and 6x minus 3 is greater than negative 15. Okay, take just a second, solve each of those two-step inequalities. All right, so we have x is less than 3. On the other one, we'll add 3. All right, so we have x is less than 3 and greater than negative 2. So let's think about that. It's less than. If we go back to our list, less than means it's and I think I forgot to do this in the last one, but I'm going to put the word and there so I know our graph should be squished together, our answer should be together. So what I'm going to do on this one is I'm going to go ahead and I'm going to come down and I'm going to sketch out the number line. So I've got negative 2 and I've got a 3. All right, so less than 3, that's an open circle and to the left. Greater than negative 2, that's an open circle and to the right. So they meet. All right, and because our lines meet, again, I know that it's an and, so I can use that to make my answer. So I can say negative 2 is less than x is less than 3. And there are the two parts to my solution. Okay, here's example number 5. And take a look at it for just a second. Does anybody notice something that's off just a tad? Okay, back when we did absolute value equations, we said that the absolute value could never be negative. So if we had the absolute value of something equals a negative number, we automatically said, oh, that's no solution, that doesn't work, what's it going to be? And so now we see this negative number over here, and there's a less than or equal to. So we're not just going to jump to conclusions. We're actually going to start working it out first. We need those absolute value bars by themselves before we can make a decision on, yeah, it works, no, it doesn't. Okay? So what's on the outside of the bars? Negative 15. How do we get rid of that? By adding 15. So it gives us the absolute value of 4x plus 2 is less than or equal to 10. Now, we have to think, could the absolute value of this quantity be less than or equal to 10? Yeah, it could. This is a positive. It's okay. We can keep going. So we're going to create our two inequalities and solve those. So 4x plus 2 is less than or equal to 10. 4x plus 2 is greater than or equal to negative 10. We can solve each of those. So we subtract 2, get 4x is less than or equal to 8. So x is less than or equal to 2. And I am skipping a couple steps, but we've been solving equations for a little while, so you should be fine and you should see what's happening. So on the other one, subtract 2, we get 4x is greater than or equal to negative 12. X is, oh, I made the wrong symbol. X is greater than or equal to negative 3. Okay, again, that's less than, so these are going to be and. We can put those together. X is in the middle. It's less than or equal to 2. Less than or equal to, it's bigger than negative 3. Okay, and then graph those on a number line. Both of our circles are closed because there's the equal. And if it's and, our line, our solution should be right in the middle. So that problem worked out just fine. Okay. Okay, so here's number 6. We have the absolute value of 2x plus 5 is greater than or equal to negative 7. So this one is similar to number 5. There's something about this that should make a little alarm go off in our brains. It should make us think about things for a second. And it's that negative. Okay, again, before in equations, we couldn't have absolute value equal to a negative. But since we have the inequalities, it's a little bit different. So let's think about it. The absolute value of this quantity is greater than or equal to -7. What do we know about the absolute value of something? It's always positive. Okay, so if we have a positive number is greater than or equal to -7, what do we know about that statement? Is a positive number always going to be bigger or equal to -7? Yeah, it's always going to be greater than -7. So that's always true. And if that's always true, that means it doesn't matter what number we plug in here, it's always going to work out. Because no matter what you plug in, you're always going to get some positive number. That positive number is always going to be greater than a -7. So for this one, we're going to say all real numbers. Okay, so that problem is a little bit different, but you will have one like that in your Math Excel. All right, and just because we can, let's look at the opposite of that. So if we had the absolute value of 3x minus 2 is less than or equal to -8. All right, we know the absolute value of something is always going to be a positive, right? So that's going to be some positive number. Is a positive number ever going to be less than or equal to -8? No, that's never true. So that would be no solution. Okay, I don't think you have any like that in your homework, but it's worth noting. Okay, an absolute value is never going to be less than or equal to a negative number. Okay, because absolute value is going to be a positive number. All right, so again, make sure you have all these notes written down. Make sure you have the examples. Use them on your math homework. And if you have any questions or concerns, make sure you let me know. Have a great day.